to the session. Greeting of the day. In today's class, we are going to see about the next topic of eddy current inspection testing. Previously, we have seen various types of NDT inspection methods, on that radiography methods, liquid content testing methods, eddy current testing methods are available. Out of all these things, I am going to concentrate with this eddy current inspection methods as of now. See, in eddy current inspection, it has its origin nearly in the year of 1831, and then its development as a non-destructive testing technique also used nearly in the recent past of from World War II onwards. They are using this eddy current methods long back. And eddy current testing, sometimes we are calling it as widely used in all fields. It is used, but a few I have given, such as aerospace industries, maybe the manufacturing, or maybe in the in-service inspections also we are giving, like maybe in the weldings, forgings, castings, or any aerospace applications, railway track applications, any other applications we can use. But only one small thing we are going to do, importantly on surface and importantly on thin materials. Importantly on these two categories we are going to concentrate. The radiography methods, we have done inspection when the system have the subsurface inspection, subsurface cracks or subsurface discontinuities. But here, this eddy current, we are going to concentrate on the surface cracks, or maybe the crack which is connected to the surface. Otherwise, any thin material cracks, it means our zone of inspection will be on the thin plates only. So, if the defects are available in the thin material, it means near surface zones. I am calling this as a near surface, or maybe thin material, or maybe surface cracks, which is connected to the surface. Those things are possible to detect by eddy current inspection methods. We will see one by one. Eddy current. Before going to the content of eddy current inspection, I want to know about what is meant by eddy. The name says it is a eddy current testing process, that we use eddy current to do the test. But what is meant by that eddy? We should know. The eddy currents are somehow the electrical currents that induced within a conductor. It means we should use the conductor materials only. See, we are going to use only the conductor materials. May not be the wood, may not be the plastics. By varying a magnetic field, when the current is passed over there, it generates usually the EMF magnetic field will be generated. We are using that principles to generate again the eddy current and again the eddy magnetic field. With respect to that, we are going to find. So it is just the opposite of that magnetic particles inspection. So we will come upon, because we are giving some other concerns here. We are talking about eddy current. This magnetic particle inspection, MPI, magnetic particle inspection, it is quite opposite, maybe quite opposite to that of eddy current inspection. So we are talking about this eddy current inspection. It's not, both are not same. There also we are using magnetic particles, here also using some eddy current, both we are using some conductive materials. But the method is different, therefore just to give some controversy statement, it is not correct. It's not quite opposite, not same. They get either, it means the eddy current, they get either name from eddies that are formed when the liquid or gas flow in a circular path. So this is what we are calling this as a eddy. Around the obstacles and the conditions are right. You see, let us assume we know what is waves, what is frequency. We have a little bit discussed these things also. It means throwing a stone on a water causes some waves. Maybe multiple waves will be generated. We have already seen this also. I am calling this as waves, and we identified this is around wavelength. And we know the frequency is nothing but how many these waves cross per second. If in case more waves, more force is there, then more waves will be generated. One pushes the other, and the frequency will be higher. More waves per second. Now, how this generation of this waves in a circular format, I am calling this as eddy. So this generation of waves in circular format is called as eddy. How we are relating to our eddy current? Eddy current, when we are sending some current over there, otherwise let us take between the flow of water path, let us take some obstacle is there. Therefore, in this obstacle, maybe the water flow first it goes in a straight path, and therefore when it is hitting this obstacle, it is the flow path is disturbed by the obstacle. Therefore, it is getting some interpretations, and then when it is coming outside, it is coming like a rounds. So this obstacle makes some curves. So that curve is in the round shape, which is in the eddy format. With respect to this understanding, you see, similarly, I am comparing this part of this point of waves. Here it is generated waves in the eddy format, like this. I am comparing this with our setup. Our setup, how we are creating this eddy current on the specimen or test coupon. See, this is our specimen, which is we want to do inspection. When alternating current we have given to the copper coil, maybe a conductive material, and we are giving some current. When the current is passed over there to the copper coil, by this primary current, I am understanding this is a primary current. Primary current. We all have to see this again in the upcoming slides also. Primary current, the magnetic field will be generated. And also, with the primary current is passing through the specimen which we are going to inspect, and it is attracted over there. Due to this primary current passing over the other specimen of the other conductive material, there the one more current is generated by this incident primary current. That I am calling this as a eddy current. So here I am setting the primary current, the generated one is a eddy current. Eddy current. But it is not in any other format, it is in the format of the eddy format, circular format, which is on the flat surfaces. So when I am trying to draw here, you see, I am doing some drawing here, see. I want to do inspection on the specimen. This is a flat specimen, and I am having the copper AC current coil in this way. Therefore, the eddy forms on the surface. It means that over this surface it is formed here like this. We have to look over the top view. If we are looking over the top view, it is a surface like this. It is creating on the top surface, eddy is created. The circular path. It is not going deeper. It is circulated the surface and it is going. Current is generated like this. And is going. So that is what from the top I am doing. So here it will be. So that is what drawn here. It is on the surfaces it is elaborated. On the surfaces it is elaborated. Top surface. So that is called as eddy. And then with respect to this eddy, the secondary eddy magnetic field generated. So we will here also if you can write here the one it will be generated. This is called as a primary magnetic field. And similarly, from the bottom due to this eddy current, here it will generate something. So that is called as a eddy magnetic field. We come to this picture there in the second slide. So likewise this is named as eddy. So they get either names of eddies that are formed when the liquid or gas, maybe a liquid or maybe the glass, flows in a circular path around the obstacles. This is some around the obstacles when the conductive conditions are right. If flowing water encounters any obstacles like maybe a stones or rock, it tries to go around it in a circular path. So same, this is what I am doing. So a sprinkling of water around these obstacles is called as eddy. So finally we are giving some acceptance of this is swirling of round is called as eddy. But here to our condition, due to supply of primary current, it is generated on the plate or the inspection plate. Maybe what is the properties of eddy now? Why we are using this eddy current inspection? By using eddy, it means we are doing a non-destructive inspection through eddy, not in the other methods. Maybe we are doing in the other methods also. But you see, it can flow through closed loops with the conductor. So if the specimen is in the conductor, we can able to do this eddy current inspection. If it is not with the conducting method, then the surface detection can be done through the liquid LP inspection maybe. So likewise, so the property of eddy currents, it should be a conducting. This eddy current flows in a plane that is parallel to the coil winding or the material surface. So you see, we have generated the coil in such a way, the coil is there, so parallelly the current will flow downwards. They alternated and lag in the phase with respect to depth. This point we will understand with respect to some diagrams. Here you see, the alternation word means it is obstacle, it's reducing. 100% we have released of current, but it has to penetrate into the workpieces. Here it is AC is released. It has to penetrate here. When due to this eddy current generation on the top surface is this much, it means I will draw like this length. But at the same time, when it is going deeper, due to this reflection of the two currents, let's say, we'll take one more image here. We take this image, the working principle. I have supplied the eddy current of AC supply here on the conductive material, maybe a copper. Due to these reactions, we are getting some primary magnetic field. I have mentioned this in blue color. This is a coil. So I have written this is a coil. So here we can write it. Okay, here this is a coil. And then this coil generates a EMF, maybe a magnetic field. I have mentioned this in the blue color. So it is the primary magnetic field. Primary magnetic field. Magnetic field. And this primary current is passing over the specimen at the bottom of the conductive material again. See, this is also conductive. So that is what the property it is mentioned. It is to be a conductive material. The flow of closed loop within the conductor only, not in any other non-conductive material. To the conductive material. Due to this, what happens? One more secondary current is generated on the specimen, which is in the circular format that we call as eddy. Therefore, I am naming this as a secondary current. I am naming this as eddy current. I have given here it is a eddy current, which is created on the surface, and it reduces down with respect to effect of this attenuation process. Due to this generation of this eddy current, as like the primary magnetic field generated by the primary current. Here I have written this is primary current. I have written here as a primary current. Primary current. Due to this primary current, primary magnetic field, that is blue color, is generated, and this primary current gives supplied on the conductive material, which generates one more current, like called secondary current. Secondary current, which I am naming this as eddy current. Due to this eddy current, as like primary current, primary magnetic field due to this eddy current, eddy magnetic field will be generated. In which format? It will be in the upper direction. This is coming downward direction. This eddy current, eddy magnetic field will generate in the upward direction. That I am drawing in the yellow color. You see, like this. Like this, it is generating. So likewise. Likewise, it is generated. So the green color circle is eddy, it is generated on the surface. Magnetic field is generated in this spot, as like this wave formats. Now what happens? This primary magnetic field and eddy magnetic field are opposing each other. It means due to this opposition, my intention is do inspection. Doing inspection, this primary current has to pass through. It means the generated eddy current has to pass through inside. As because of supplied 100% of primary current, so 100% of eddy current will form here, or 80% due to alternation, or 80-70% will form here. But due to keep on the opposing forces, here the generation is going to reduce. You see, here the length is like this. So this is the total length. And then we will talk in black, looking good. So it is in this edge. Then the primary current passing through is opposed by the eddy magnetic field. Therefore, it is facing primary current is facing some difficulty to give its 100%. Then the amount is reduced. Therefore, generation of the eddy current amount also will get reduction when it is going in deeper. So here what happens? It can go up to this much only, and later it can go up to this much only, and later it can go up to this much, and later it can go up to this much. So the eddy current diameter is reducing. You see. So one type of scale we are getting here. This like this we will get. See, it is getting a reduction. That is what I have drawn final picture here. That is what I have not shown there. First I am drawing here and then I am showing. See here, it is likewise. So the current is supplied on the conductive material. The blue color belongs to primary magnetic field, and then this yellow color belongs to maybe the eddy current. Due to this eddy current, the eddy magnetic field is generated, and it is also here it is opposing, and due to this opposition, it is going to reduce eddy current. Induced eddy current is reduced. Induced eddy current not for going deep. So it is getting reduction. It is getting reduced. If it is reduced, it is not going deeper. It is not going. Only for few it is okay. 180% is okay. If eddy current having some 40 to 20%, it cannot able to reflect back, or the results may not be perfect. We are not using that. That's why, for this reason, I have given at the beginning, as on the first slide, it is only possible for thin materials. You see, here I have given as a thin materials. It is requires inspection of thin materials. So that is the reason. It means eddy current is reduced when it is going deeper due to its attenuation process. What is this attenuation? Both are getting reflected and both are getting opposite direction. Therefore, it is the primary current what we have supplied. It is not full-fledgedly not possible to go deeper. If it is not going deeper, eddy current is also not generated. If the eddy current is also getting a small low quantity of amount supplied, and it also eddy current generation also getting smaller. So therefore, again, it is not possible to get the exact good results. So that is how this attenuation is blocking, only limiting the inspection for thin materials. And maybe in the surfaces it's okay. If the surfaces cracks are there, then we can able to find, because its surface 100% is falling. Surfaces, even the attenuation is there, it is giving some projections. But the projection is not possible when we are going deeper part. Therefore, it is limited to thinner samples only. We will come back again. So that is how they alternated and lagged phase with respect to depth. That is our understanding now. So, say only for conductor and panel the coils, and they alternated and lag in the phase with respect to depth. Depth is not possible to move because of the alternation opposite reactions between the primary magnetic field and eddy magnetic field. The remaining part of the subjects, we'll see you in the next session. Thank you.